these two rows don't work well together, they are not in sync, then something is terribly wrong. So can anyone tell us from 1 to 1.36, what does the function increases? Is that supported by the sign of the first derivative?
Yes.
Yes. From 1.36 to 2, what does the function do? Yes. Is that supported by the sign of the first derivative as we discussed? Perfect. So now, what type of point is 0, 1? What type of point is 1, 1.36? And what type of point is 3, 2? So let's start with 0, 1. What will you say that represents for this function on the given interval? Zero, 1. What does it represent?
So I have a question.
Yes.
When we're talking about the domain, does that mean the function only exists at that, well, not domain, at the, like the 0 to 3?
That we are asked to find the absolute max min. We're asked to find the absolute max min on a closed interval.
Okay.
So in other words, the world is this for this function right now.
Okay.
Yes, very good question. So 0, 1, what does it represent? For this function on the given interval.
It's increasing on the one side, but it's...
What type of point? What type of point is 0, 1?
Close point?
Correct. What type of point? Zero,
Would that be the absolute minimum?
Absolute minimum. Absolute minimum. Awesome. What about 1, 1.36? Is it anything? Nothing.
No.
Yes. Finally. Exactly, because it goes through it up. What about 3, 2? What type of point is 3, 2?
Absolute max.
Absolute max. Question. Can 3, 2 be a relative max?
Yeah.
It's at the end point.
Not if it were looking only until 3, because we don't know what happens on the other side.
Exactly.
Okay,
so,
but if the absolute max wasn't on the end point, it could be both, right?
Yes.
Okay.
But if it's at the end point, it cannot be relative.
Got it.
Awesome. Great job. Good. So let's look at another. I like to choose something with log, something with arctangent, or something to see other functions, and also a function with trig in it. So I'm ready. That's my page 7. Anyone would like to choose, or I will?
$62.
Okay, 62. Let's take a look. What is 62 all about? Okay. F of x equals 1 plus cosine squared x between pi over 4 and pi. Awesome. Good pick. I changed theta into pi. So the world for this function is pi over 4 to pi. F prime of x and f of x. Yes, we have to find f prime of x. Can anyone give us f prime of x? Can anyone help with that? F prime of x, can anyone give us f prime of x?
Sin x squared.
So we bring down the power.
Oh.
We subtract 1 from the power. And now we differentiate the inner function. What do we get when we differentiate the inner function?
Isn't it 1?
The inner function is cosine. So we have an outer and we have an inner. We differentiate the outer, we bring down 2, we subtract 1 from the power, times the inner function prime,
So sin x.
but negative.
Okay.
So negative 2 sine x cosine x. I have to analyze 2 different things, but these are no tangent or cotangent, secant, cosecant, so there is no such case. And I have to set it equal to 0. Negative 2 sine x cosine x equals 0. Since this is a product, there are 2 options. Either sine is 0 or cosine is 0. Can anyone tell us when is sine 0? And remember, sine is measured on the y-axis. Where is sine 0? On the unit circle.
At pi and 2 pi.
Yes. So you mean at 0 and at pi.
0.
Perfect. 0 I don't have, but pi I do. Because it says it's between pi over 4 and pi. This is the domain of this function. So I don't have 0, but I do have pi. Awesome. So I did put it in. But now cosine is 0. Where? Where is cosine 0? And remember, cosine is measured on the x-axis. Where is cosine 0?
Pi over 2 and 3 pi over 2.
Yes, exactly. Since we only have between pi over 4 and pi, I can only put in pi over 2. Perfect. Awesome. Now we have to study the sign of the derivative. And of course, we have to plug this and this and this in the function to determine the actual point. So I'm going to plug in the function in the graphing calculator. Okay, in y equals, clear. Okay, and I want to make sure that the mode is in radian mode. It is. So I have 1 plus cosine squared. Okay, and I'm going to plug in pi over 4. I'm going to plug in pi over 2. And I'm going to plug in pi. So I got 1.5. I got 1. And I got 2. Perfect. Now I have to study the sign of the derivative. This is the derivative. This is the first quadrant between pi over 4 and pi. Between pi over 4 and pi, I'm going to just write first quadrant. Okay, so what is the sign of sine in the first quadrant? The sign of sine?
Positive.
Positive. The sign of cosine in the first quadrant?
Positive.
Good, but there is a negative in front. Now this is the second quadrant. Good. In the second quadrant, sine is in the second quadrant. Anyone, please? Sine is measured on the y-axis. So then sine has what sign? In the second quadrant.
Positive,
Yes. What about cosine?
negative,
Negative. Positive, negative times negative. What will be the sign? Positive times negative times negative.
positive.
Excellent. Moment of truth. Right now, this is when I catch my mistakes, if any. If these two rows do not make sense, do not work well together, they're not in sync, I'll say, oops. Okay, so let's see. From 1.5 to 1, what does the function do?
Decrease,
Is that supported by the sign of the derivative?
yep,
Excellent. From 1 to 2, what does the function do?
increase,
Is that supported by the sign of the derivative?
yep,
Finally, we have to make a decision. What type of point is pi over 4? Now, what I normally do, and I will do this now. So this is 1.5. 1 is here, and the height of 2 is here. I'm not graphing the function. I'm just giving you the y values. This one is at 1.5. This one is at 1. And this one is at 2. Very easy to picture and understand what's happening here. What type of point is pi over 4 comma 1.5? This point. What type of point is it? Because I have to write it underneath.
An absolute maximum
My ear gonna be
or relative?
ring,
No, nothing.
It's at the end point of the interval.
It's at the end point, but there's a point above it and a point below.
Very good, which means nothing. What type of point is pi over 2 comma 1?
oh, relative minimum,
Yes, and also absolute. Plus absolute minimum, right here. Awesome. What type of point is pi comma 2? This one. Pi for x, 2 for y.
absolute max,
Very good. Is it local or relative?
no.
No, because it's at the end point of the interval. Awesome. That is awesome. So clearly this is nothing. It comes down to an absolute and relative minimum because I can also show the open interval. It's in the middle. And then it goes up to this point where it's the absolute maximum. It cannot be relative because I cannot show the open interval. Awesome. Great job. Great job. How do we feel about relative max, relative min, critical numbers, and studying a function on a closed interval? Let's also choose a natural log at least. So we have 3 different ones. And I'm on page 8. So anyone? Would you like to look at 65? Is that okay? Would you like 63? You choose. Anyone? $63 or 65? 1, 2, 3, or I'll make a decision. And my computer needs some juice. No preference? Do I get to choose then?
Yep,
Okay, then I was hoping you would choose, but I'll choose 63 then. So f of x equals x to negative 2 times natural log x. The interval is 1/2 comma 4. Okay. So this is the interval, no discussion. So this is 1/2 comma 4, f prime of x, f of x. Good. So of course we have to differentiate. Can anyone tell us which rule applies here? Which rule we have to apply? Anyone can identify this?
Product.
Yes. First function prime, -2x to -3 times natural log x plus x to -2 times natural log x prime, which is
1/x.
excellent. Now this is really not helping at this point. I have to go back to basics. So -2 natural log x over x cubed plus 1/x cubed. Because I bring this down, 1/x squared times 1/x is 1/x cubed. Nice. Same denominator. I love it. So I'm going to write -2 natural log x plus 1 over x to the third. So now, critical numbers. They come from two sources, from f prime being 0 or from f prime being undefined. When is this function undefined? For x equals blah, blah, blah is undefined. Well, first of all, it's undefined at 0. It's also undefined to the left of 0 because natural log does not exist. But we don't have to worry about it. 0 is not in the domain. We have from 1/2 to 4. So there is nothing that I can put in the table because it specifically says 1/2 to 4. So I have to set it equal to 0. When is a fraction 0? Any fraction is 0 when?
The numerator is 0.
Excellent. And the numerator is -2 natural log x plus 1. And now I have to dig deep and see how I solve this. Of course, I'll move 1 to the other side. I'll divide by -2. How do I take it from here? This is a log equation. And we know that log base b of x is y is equivalent, double equivalency. The log equation changes into an exponential, the exponential changes into a log. What do I write here? This log equation is equivalent to an exponential equation. Which one? Once I have this equation, I can solve.
Y equals
Careful. We start with the base. The base to power y
base
equals-
to power y.
equals x. Counterclockwise, like this. Base raised to y equals x. This is a very important property that helps us convert log exponent equation into an exponential equation back into a log. We always start with the base and we go counterclockwise. It's not b times y. It's b raised to power y equals x. So coming back here, how do I solve this equation? Can anyone tell us how to write it based on what you see here? So the equation is natural log x equals 1/2. Natural log x equals 1/2. This is equivalent to, first of all, what is the base on natural log? I don't see any base. What is the base for natural log? Always.
Is it 10?
So the log has base 10. The ln has base e. So log goes with base 10. And very easy to remember. Allow me to share my screen for a moment.